Okay. So it's a simple problem in this circuit. So they have given parameters of transistor. Beta value is 100. I'm going to use a silicon transistor. So silicon means you have to use VBE as 0.7. Okay, silicon means it is understood that the cut-in voltage of the diode is going to be equal to 0.7 volt, 0.7 volt. Okay, so that is given indirectly in this question. They have also given the values for VCC, RC, and RB. They are asking you to find the Q point. Also, what the stability factor. So it is given fixed bias circuit. Okay, so first for drawing the stability factor, we have to go for this equation. I told you this is the only equation which will help you draw the load line for your common emitter amplifier. VC equal to VCC minus ICRC, or I can write VCC equal to VCE plus ICRC. Anyways, you do it, it is going to be correct. So first case, put IC equal to 0. So if you put IC equal to 0 in this equation, you get VCE equal to VCC equal to 6 volt. So the maximum VCE which you get transistor can withstand is 6 volt. And when you put VCE equal to 0, I can get IC equal to VCC by RC. VCC is 6 volt, RC is 3 kilo ohm, so you get 2 milliamperes. So maximum current flowing through your device is 2 milliamperes. So I got the two extremes, maximum voltage and maximum current. With these two extremes, I can draw the DC load line. So see here, x-axis is voltage, y-axis is current. The maximum voltage is 6. The maximum current is 2 milliamps. Draw a line joining these two. This is your DC load line. Is the process of drawing the DC load line clear? Okay, the process is very, very simple. So DC load line, we are going to use the collector side KVL equation only. VC equal to VCC minus ICRC. You have to put two cases for marking the endpoints. One is apply IC equal to 0. This is your open circuit condition. Put VC equal to 0. It is your short circuit condition. So find the endpoints of the DC load line, 6 volt and 2 milliamperes. Okay, it is going to be 6 volt and 2 milliamperes. So you are marking that. So the Q point will be exactly in the middle. So Q point will be 6 by 2, it is 3 volt. 2 by 2, it is 1 milliampere. So the Q point coordinates are 3 volt and 1 milliampere. Okay, 3 volt and 1 milliampere. This is the coordinates of your Q point. So that is one thing asked in your question. Okay, so we have got the coordinates of Q point. See here, VC is 3 volt and IC is 1 milliampere. And this is not over actually. They have also asked determine the operating point and what is the stability factor. So stability factor, you know, it is 1 plus beta. Beta value is given as 100. So stability factor will be 101. And we have also need to design the value of, we also find the value of IB. So given RB is given, so you supply the KVL equation at the base side. So you will get VCC equal to VBE plus IB RB. From this, if you rearrange, you can get the expression for IB. IB equal to VCC minus VBE by RB. VCC is given 6 volt. Silicon transistor is given, so VBE is 0.7 and RB value is 530K. If you substitute, you get the IB is 10 milliamperes. And you know IB, sorry, it is 10 microamperes. It is given wrongly. It is 10 microamperes. And IC is beta into IB. You get the value of IC as 1 milliamperes. Okay, so this is the operating point. VCEQ is 3 volt. Directly also you can write 6 by 2 is 3, 2 by 2 is 1. Directly also you can write, or using the KVL equation also you can come to a conclusion about the operating point of fixed bias circuit. Is this problem clear to everyone? Anybody is having doubts, please ask immediately. Procedure is same for all the problems. Only thing, the circuit will vary. Accordingly, your KVL equations will slightly change. Any doubts, please open up and ask. This circuits class is bound to be interactive. Only when you understand circuits, you can apply these circuits in your project when you do in 8th semester and mini project when you do in 7th semester. Otherwise, you cannot design circuits using these electronic devices. So any doubt anybody is having in this problem? Is it clear?
It's clear.